Earlier we have discussed the tensile strength of the EPS geoform material, and we have determined the initial tangent modulus and also the stress strain curve, in which you can determine the what should be the strength, tensile strength at the yield or certain percentage, 1%, 5% or 10%, with the different densities of the EPS geoform. Now, I will show you in the slides that this is correlation between the tensile strength in kilopascal and the density of EPS geoform kg per meter cube. What will be the correlation between the tensile strength and the density of the EPS geoform under different density of the EPS geoform, starting from maybe 15, 20, 22 and the 30. You can see you can draw each tail line and you can determine that what will be the sigma t, that is 17.14 into rho minus 116.9 or R square is equal to 0.981. So, for knowing the density of the EPS geoform material, you can determine what should be the sigma t value. Now, we will show you that proposed tensile specimen, test specimen of the tensile strength of the geoform material. And this proposed tensile strength of the geoform material is developed by IIT Bombay, and it is much more simplified than the earlier ASTM tensile strength of the EPS geoform material. In this proposed tensile strength test, the test specimen has a thickness of about 25 millimeter with a flat section. You can show the figure here, and in this figure here the shape of the sample is like this, and the size of the sample is from here to here is 500 millimeter, and from here to here is 250 millimeter, and this is 25 millimeter, and from here to here is 75 millimeter, and from here to here is 170 millimeter, and this arc is 25 R, and this arc is 90 R, and this distance is 150 millimeter, and this is 140 millimeter. So, this is the schematic representation of the tensile strength of the proposed testing specimen. So, the shape of the EPS geoform sample is like this, and whose thickness is also 25 millimeter. So, from any panel or any density of the EPS geoform, you can simply cut the sample as it is shown in earlier figure, and then you can perform the test in a universal testing machine. So, this is much more simpler way to prepare the sample than the ASTM method, which is very complex to prepare the specimen for the EPS geoform material. So, next I will show you the defined types of the specimen. So, you can see that this is under the different density of the sample, that is 15, this one is 20, this is 22 and this is 30. So, tensile strength of the test specimen from left to right is 15, 20, 22 and 30 kg per meter cube. So, this sample are to be tested in this gripping assembly. Here is the gripping assembly. So, this sample has to be gripped with this gripping equipment. So, if you can perform the test, you can see here this is the sample and you are using the universal testing machine to perform the tensile test of the EPH geoform under different density. And this is the sample, you can see here. After the test, you can find there is a failure here, you can see there is a failure of the EPH geoform. It is failed at the center of the sample. It should not fail at the edge or near to the campling. So, you can discard the sample, again you prepare another sample and then you perform the test, in order that sample generally should fail at the middle of the EPH geoform material. I will show you some other type of the EPH geoform sample with the defined density, and you can observe that what kind of the failure it is. So, here tensile test, strength test of EPH geoform, and as I say with density 15, 20, 22 and the 30 kg per meter cube. This is before the test, this for before the test, and you can see after the test. In some sample is not at the edge, some sample at the top and sometimes at the bottom, and some sample at the center of the EPH geoform material. So, it is preferable that sample should fail at the middle of the sample. I am showing you that when you perform the test, you can see that defined types of the failure pattern. So, what type of the failure pattern you should accept and what you can have the exact result for the tensile strength of the EPH geoform material. So, from this EPH geoform on tensile strength of the EPH geoform material, you can draw a relationship between the tensile strength and the strain value. I am showing you some curve. This is the figure, tensile stress versus strain behavior of EPH geoform. This is the tensile stress in kilopascal and this is the strain in percentage, and this is also in different density of the EPH geoform. This is 15 kg per meter cube, 20 kg per meter cube, 22 kg per meter cube, 30 kg per meter cube. And you can see the stress strain curve. The stress is tensile stress is increasing with the increasing of the strain of the EPH geoform material. There is no specified failure of the EPH geoform during the testing of the tensile strength of the EPH geoform material. But you can also observe from this figure that there is an increasing of the tensile strength of the EPH geoform material with increasing the density of the EPH geoform material. You can observe that 15, then you are having the more value for the tensile strength for the 20, if you are having more value for 22 kg per meter cube, even then more 30 kg per meter cube. So, whatever you require for your particular project, so then you can select that what tensile strength is required and what density of the EPH geoform you should accept. So, you can have the idea from this. So, next I will show you that what should be the table that which we have prepared for the ASTM D162309 and with respect to what are the proposed tensile strength tests at IIT Bombay. So, here look that density of the EPH geoform is kg per meter cube. This is 15, 20, 22 and the 30. As per ASTM D162309, the tensile strength of the EPH geoform for 15 density it is 154.89 and corresponding strain at failure in terms of percentage is 2.56. Similarly, for the EPH density of 20 kg per meter cube and tensile strength is 216.40 and strain at failure is 2.71%. For the density of EPS is 22 kg per meter cube, then tensile strength of the EPH geoform 244.54 kilopascal and corresponding strain value is 2.74%. For the density of 30 kg per meter cube of EPH geoform, the tensile strength is 407.78 and corresponding strain value is 2.82. So, this is as per ASTM D1623 and this value we have compared with the value of our proposed tensile strength test machine in IIT Bombay, which is ISEP type of the sample. So, tensile strength you can see for the density of EPH geoform 15 kg per meter cube and tensile strength as per IIT Bombay is 154.13 and the corresponding strain at failure is 2.23. Similarly, for the density of EPH geoform 20 kg per meter cube and the as per PTST the tensile strength of the EPH geoform 216.16 and corresponding the strain at failure is 2.62%. Now, for a density of EPH geoform 22 kg per meter cube, this as per PTST the tensile strength of EPH geoform is 246.88 kilopascal and corresponding strain value at failure is 2.63. For the density of EPH geoform 30 kg per meter cube, the tensile strength of the geoform material as per PTST is 411.56 kilopascal and corresponding strain is 2.74. So, if you can compare both the ASTM and the PTST method, you find there is almost the similarity of the tensile strain and the corresponding the strain at failure. So, there is no differences between the ASTM specification and with the IIT Bombay proposed tensile stress machine. And we see in our case that sample preparation is very easy. You can take a panel of the EPH geoform whose thickness will be about 25 millimeter and then you can cut the sample in the I shape. So, it is easy to cut in the I shape and then you can perform the test of the EPH geoform material. So, we are having quite good or reasonable result with respect to the ASTM test specification or method. So, for the present IIT model, it will be very easy to prepare the sample and to perform the test. So far we discussed about the tensile strength of the EPS geoform material under different density of the EPS geoform as per STM method and as well as for the IIT Bombay method. So now we want to discuss the shear properties of the EPS geoform material. So shear is important, one of the properties, because there will be the shear between the geoform to geoform material, or there may be the shear between through geoform and the concrete, geoform and the soil, or geoform with any other foreign material when it will come in contact. So how you are to perform the test, the shear properties of the geoform material. This is as per ASTM C273, and this is as per ASTM C273 C273M07A. So here main objective to determine the shear strength parameter of the EPS geoform material, and this test specimen shall be 300 millimeter by 50 millimeter into 25 millimeter. So here you can see that this is the EPS geoform specimen, and this is about 300 millimeter, and this size is 25 millimeter, and this size is the 50 millimeter. From here to here 50 millimeter, here to here 25 millimeter, and from here to here is about 300 millimeter. So this is the schematic representation of the EPS geoform material. Here the shear strength test specimen with different density. So this is for 15 kg per meter cube, and this is the EPS geoform with density is 20 kg per meter cube. This is the EPS geoform with density about 22 kg per meter cube, and this is the EPS geoform with density is 30 kg per meter cube. So we will perform all the tests under all the different density of the EPS geoform material. So for this kind of the test, you require that apparatus, what kind of apparatus you want to use, and how you perform the shear between the two geoform material. So here I will show you that apparatus, that is you require testing machine, and this is force measuring device and deflection measuring device. So this is the shear test assembly for geoform. It is developed in IIT Bombay, and you can see here this one plate on the left hand side, another plate in the right hand side, and geoform, EPS geoform material is placed between the two plates. It is here. So this plate shear specimen of the EPS geoform and the force of line of action. So it is acting on the acting upward, and this is also force acting in the downward. So this is the steel plate. So you can perform the test using this shear machine. So from this testing method, how you are attaching the sample and what will be the testing procedure, that I wanted to show you. Here you can see that attach the specimen, okay. This is the specimen attached with the loading plate, and here is attached with the loading plate and install the assembly in the testing machine, and then you can apply the load and record the mode and the location of the failure. So, here it is the shear strain test of the EPH geoform under different density of the EPH geoform material. So, now from this test how you can calculate the shear stress. So, I will show you how to calculate the shear stress of the EPH geoform material. So, here I am showing some calculation how to determine the shear stress. So, it is expressed as tau. So, shear stress tau is equal to P divided by L into B. So, where this tau is the core shear stress. Okay? So, let us say this tau is the core shear stress and unit is kilopascal. And P is the instantaneous force on specimen. So, this unit is Newton. And L is the length of the specimen. Length of specimen, and that is in meter. And this is B. B is width of the specimen. Width of the specimen, and that also in meter. So, from this test you can determine what will be the maximum shear stress. You can determine maximum shear stress, and that is designated at tau of max. And this tau of max, writing that again, that tau of max is equal to P divided by L into B. So, this is maximum shear stress you can determine. So, if you know the P, if you know the L, if you know the B, you can determine maximum shear stress value. You can also determine what will be the core shear modulus. So, you can determine core shear modulus, which is designated as G. So, G you can write is del of P divided by del of U into T, this divided by L into B, where del of P by del of U is equal to the slope of the force displacement curve. So, this is the slope of the force displacement curve. That means Newton per millimeter. And this, from 0.0022 millimeter by per millimeter to 0.006 millimeter per millimeter effective engineering shear strain. Engineering shear strain. So, I am showing you the table in these slides, that how the specimen calculation for the determination of shear strength of the geoform material. So, this is the density of the EPH geoform in kg per meter cube for 15, 20, 22 and 30, and this is the maximum load at failure. Let us say for 15 density 1255 Newton, for 20 density 1.16 Newton, and for 22 density is 1823 Newton, and for 30 EPH density is 2089 Newton. This is the maximum load at failure, and it determine what will be the shear strength in terms of kilopascal. You can see for 15 density 83.65 kilopascal, for 20 it is 94.4 kilopascal, for 22 is 121.57 kilopascal, and for 30 EPH geoform is 139.27 kilopascal. You can measure the deformation at peak load in millimeter. Is for 15 density is 5.62 millimeter, for 20 density is 4.67 millimeter, and for 22 density is 4.31 millimeter, and for 30 density it is 2.67 millimeter. So, from this you can calculate the what is delta P by delta U from the graph. So, this is for 15 density, delta P by delta U is 668.18, and for this 20 density it is 855.88, and for 22 density it is 902.36, and for the 30 density it is 11309. And you can determine what is core shear modulus. I have shown you the earlier equation, and from there you can determine the core shear modulus. So, core shear modulus value is given here for the 15 density 1113.633, for 20 density 1426.467, and for 22 density 1503.933, and for 30 density 1884.833. And here I am showing only one calculation for 20 density, considering density of the EPH geoform is 20 kg per meter cube, and P is equal to the, this is 1.416 in kilonewton, and then you know the P and you know the length of the sample 0.3 meter, and you know the width, that is about 0.05 meter. So, from the tau maximum, that means core value, you can determine from this 1.416 P divided by L into B. L value is 0.3, B value is 0.5, this is 94.4 kilopascal. So, you can see that shear strength value for the 20 kg per meter cube of geoform material is 94.4. So, what you find from this shear strength value, that shear strength value is increasing with the increasing of the density of the EPS geoform material. So, this shear strength of the EPS geoform is required when there is a interaction between the geoform to geoform material.